So we've spoken about modulus and we've spoken about mathematical operations. And I kept saying that a math operation is like plus, minus, division, multiplication, but what's happening is I have two numbers and I'm doing something and then I end up with a single number. Exactly what happens is decided based on, the plus or the minus or whatever the symbol in the middle is. So now we're going to go on and talk about logical operations. Now, the difference between a logical operation and a mathematical operation is, let's just call it logic ops. The difference between a logical operation and a mathematical operation is a logical operation is going to give us back logic. But a logical operation doesn't need to actually put in two pieces of logic. We just need to make a logical sentence. We just need to say a logical sentence. So a logical sentence, for example, would be, my shirt is green. So I know it's kind of hard to see in this light, but that is actually a true sentence. A false sentence would be, my shirt is blue. My beard is orange would be a true sentence. My headphones are in ear. That would be a false sentence. Or my headphones are pink would be a false sentence. So those are sentences that I can say naturally. A computer doesn't inherently understand what headphones, what pink, what anything like that are. So when a computer understands logic, we have a much more basic set of things. For example, very often what we're doing is we're comparing numbers. So for example, I say 5 is greater than 7. And that is either true or false. In this case, it is false, right? So this is the first thing we have. We have the greater than. Right? This is one comparison. Greater than. The next one is less than. So I can say less. Now this is true. So if I say A equals that and B equals that, and now I print A and I print B, what is the data? What type of data is A? What type of data are A and B? The data type for A and B is going to be Boolean, right? They're logic. It's a logical sentence. It turns into a logical thing. The same way when I did, if I did 5 plus 7, I'd get back a number because that's a mathematical operation, returns a number. I'm doing a logical statement. I'm doing a logical sentence. I'm comparing. And so I get back a logical sentence. So A is going to be false and B is going to be true. So once again, I'm going to run my code and I get back false and then true. Why? A is false because 5 greater than 7 is not true, but 5 is less than 7, which is true. So I've got greater than and less than. We've got a few more operations, so we're going to keep rolling right along here. So we've got 5 equals 7, and this is where we compare. So when I say 1 equals, I'm assigning, right, like A equals 5 is greater than 7, and then I've got B, and then I've got a comparison equals, right? So that's going to be false. And then, so we've got equals, we've got not equals. So 5 not equal 7, right? And this is going to be true, right? Because 5 is not equal to 7, so I'm just going to see what these are equals and not equals. And at a certain point, this code is all going to be available to you. I will explain how to get the code in a future lesson. Because that's a different topic. It's version control. It's something that's important, but not for right now. But the reason why I'm adding these notes to the code is because the code is going to be available later if you want to reference it. Don't worry about that. So we've got our greater than and less than. We've got our equal and not equal. And notice how, remember, I don't actually need the A and B thing here. Right? I can delete that. Whoop. And delete those 3 lines. Right, so I've got greater than, less than, equals, not equals in here. Nothing's going to print out if I run the program. It just reads all these lines of code and does nothing with them because I'm not storing them or asking it to print for me. Now, so that's greater than, less than, equals, not equals. Those are the basics. The other thing to realize is that with greater than and less than, we have one more thing we can do. We have greater than or equal, and we have less than or equal. And now or The important point here is notice how the equal sign is always on the right. Whenever I do something or equal or not equal, for example, I always do the thing on the left and then the equal sign goes on the right next. The equal sign is not first. If the equal sign is first, it will cause confusion because, for example, this is a separate symbol that means something entirely different. It gets used a lot in JavaScript and some other places. In Python, I believe it also works for something, but for right now, for this stuff, we don't use it, we don't need it, it's not important, but it's important to realize that these are my basic logical statements, right? I've got just some core basic logical things, and they're all about comparing stuff. This is greater than this is less than this is equal to or greater than, equal to or less than, equal, not equal. Those are my basics. Everything else extends off of this. There's a few other logical operators that we have, but they're about adding two sentences together. For example, I can say my headphones are pink and my shirt is green. So my shirt is green is true, my headphones are pink is false, and therefore the whole sentence is false. So I've got and, right? Because these are black, not pink. So I've got an and statement, and then I've got an or statement. So my headphones are pink or my shirt is green. That's actually true, right? Because a part of it's true, the whole thing is true. In programming, we've got exactly the same thing. We've got and we've got or. So let's just say 5 is greater than 4 and 7 is less than 8. This is a complete sentence, and if I print it out, right? If I print this out, it will print out as true, right? Because both sides are true. Now if we add a few more things, we're going to add a or, and this is also going to be true, right? Because if both are true, it's still going to be true. Now I'm going to delete the rest. We're going to duplicate this again, and we're just going to make one side false, right? I'm going to say 7 is greater than 8. And now if I say, nope, that's false. Why? Because 7 is not greater than 8. Therefore, this is true and false. Therefore, the whole thing is false. But if I do the same thing for this one, right? If I say 7 is greater than 8 here, and I run this one is still true. Why? Because part of it is true, so the whole thing is true. We don't even have to check the second part, right? If the first part is false and it's an and statement, I don't even have to look at the second part. If the first part is true and it's an or statement, I don't even have to look at the second part. I already know that it's true. Those are my basic logical operators, and they always result in a true or false. Like you saw, we can assign variables to them the same way we can assign variables to mathematical operators, right? So a equals this, it will do the operation and give me back the result stored as a variable. The next thing we're going to talk about is we're going to talk about how to do operations and store in a little bit of a neater way. So that is going to be called compound operators, and those can be done with mathematical stuff, not with logical stuff. So we've covered math, we've covered some logic, and last we're going to do is compound operators, and then we're done talking about operators, and we can move on to other things.